Hi, Year 12. Chapter 2, we continue with vectors. 2C will be today about the dot product or the scalar product. That shouldn't be anything new. Let's go over this. So the notation is two vectors with a big dot in between. What it means is the same, similarly to a multiplication, you will have the product of the magnitude of each vector and the cosine of the angle between the two vectors. Um, Cosine is between -1 and 1, so the dot product will be a scalar answer that can be negative or positive. If you know the coordinates of your two vectors in 2 dimension or 3 dimension from your Cartesian plane, the coordinates, you do the respective product of the coordinates and you add all it together, and I'll give you the answer, which is kind of useful when you want to go backwards. Is you determine using the coordinates, you determine your dot product, and you want to figure out the angle in between. All right, let's look at some of the properties. So as before, it's a scalar value. Just be mindful of the notation. You really need to be strict with the notation. So, and your answers, you can't mix vectors, scalar, and the notation. A vector is a vector. The magnitude of the vector is a scalar value. The dot product is a scalar value. So any scalar value, similar, well, it's like a, think about it just to remember as a multiplication. It's commutative. It's also distributive. You can expand the brackets when you have three vectors, and um, the dot product itself is equal to the magnitude squared. So another way to figure out the magnitude is when you know the Cartesian coordinates is you just square each one of them, add it together, and that's a square, and you square root. So it links back to the Pythagoras theorem. All right, so as before, to find the angle between two vectors, you determine your dot product, you divide by the product of the magnitude, and that will be cos of theta. Useful in proofing when you want to find out that two vectors are perpendicular, or if they are perpendicular, then you can uh, find out, I mean, derive or conclude that the dot product is equals 0, and vice versa. If you calculate your dot product between the two vectors and it equals 0, then you can conclude that those two vectors are perpendicular. Okay. Um, Something else is if you have two parallel vectors that link back to the linear dependency, we can write the vector as a scalar of the other, and the scalar amount, it can be positive or negative, is the ratio of the magnitude of the vectors. So it's just an application of calculating certain values. Um, One example, so you have your coordinates in uh, 3 dimension. I'll give you a minute to figure out the magnitude of the angle. A hint, because it's asking you to 1 decimal place, is if you don't get an exact value for the cos, just as it, use a calculator and approximate the answer. Make sure your calculator is set in the correct angle. So if you write your answer in radian or degrees, just write the respective unit. So we'll be back in a second. All right. So we want to find the angle ABC. So you annotate the vector, which is B being the vertex of that angle. So it will be BA and BC. So write the vector BA, BC, and then determine the coordinates in terms of the position vector, vector A, B, and C. You write your coordinates, and then we can apply the dot of scalar product. Apply to that using the coordinates, we get the a scalar value of -3. We also need to determine the magnitudes. So we have the respective magnitude down here. And then we can rewrite this expression in terms of cos of the angle. So now cos of the angle is equal to that value. If nothing close to any exact values, so use a cas and we get the answer in angle, which is 109.1 degrees. Okay. Um, Alternatively, as I said, if you had set your calculator in radian, you need, and you can show that you're aware of that by writing your answers 1.9, and the notation is a little c suffix or exponent for the radian notation. Okay, and that's it for 2c. So see you later.